here at the University of Tartu for the Spatial Planning Toolkit, which is part of the Work Package 1 in the HyTruck project. I'll present our basically close to final deliverable, which is the Spatial Planning Toolkit app, which is meant to support planning activities and informing HyTruck fuel station spatial allocation. So where to put hydrogen fuel stations. The work package started 2023 and is due end of this year. And the next year, when the HyTruck project is still ongoing, we will still be around, of course, for maintenance and minor iterative improvements. The tool came to be as a joint sort of capabilities inquiry with our stakeholders and what we thought would be a good way to approach hydrogen fuel station planning from a spatial perspective. And the idea is to help stakeholders find good or needed locations for hydrogen fuel stations. So we had a lot of stakeholder input within the project and with associated and external partners and consultancies to review relevant criteria, which is related to data, but also to the functionality. We started with a research component as well. So some of the decisions and data are also informed by additionally through scientific literature. And so the main situation where we are now is that we can look at the at the location planning toolkit and to visualize suitabilities and present additional project outcomes. At first, I want to quickly go over 3 background concepts that were included in sort of a more methodological way. So the first thing is suitability analysis. What is that? So there are many selected criteria like distance to road, obviously, closeness to major hubs like cities, water availability, terrain suitability for construction, these type of inputs. They were amalgamated into a global grid system so that each grid cell has the same area of, in this, the base resolution for us here is roughly at 1 kilometer. And then we have some classification of the data and some weighting based on literature review and on the stakeholder inputs and interviews. And this means then based on various criteria, there will be a single suitability number for each location, which helps you to, or the planners help to inform which areas might be more suitable to construct. This is basically a screenshot of the app. You can see the grid cells right now, they're zoomed out, but if you zoom in, you get to the resolution of approximately 1 kilometer, and you can see the different shading of yellow versus more green. And this sort of, we have the web map, and then the default, the layer weighting, the input weighting, and the layer tablet on the left side where you can see all raw other input data. Then the second is the weighting, as I explained. The weighting, we have 2 default, let's say default already prepared. One is through a method called AHP. So this is literature informed. That was done through a scientific process. And so the other one is through survey. So we had interviews with more than 20 or even more partners and planners and consultants to retrieve their feedback on how to set different priorities. So on the right side, you can see the various input variables. This is something like distance to potential gas pipelines. So this related to hydrogen transport to the fuel stations. And then, of course, some things like residential areas, you don't want to have hydrogen storage within residential areas. Some information regarding renewable energy access, if there was on-site production. These were all put together, and then a suitability score is getting calculated based on the different priorities, either the AHP, let's say literature-based expert weighting, and then the survey, which is the practical expert weighting, so to say. And how does it look like? This is the survey-based weights. So we can see that they are generated from feedback from the experts. They would then grade between 0 and 5 or 0 and 10. And then in summary, would see that, for example, corridor points, meaning that it's better and closer to the 10T corridor, is higher weighted. And then distance to seashore, I mean, this is for water accessibility, but it's not as highly valued, let's say, like urban nodes, access to urban nodes. Urban nodes is basically larger cities. So having fuel stations closer or in larger cities will be a higher suitability. And the last one is then spatial allocation of HRS placement. So the point of the European directive was that along the 10T corridor, the minimal number of stations should be so that you never have to go more than 200 kilometers along the 10T core roads to reach the next hydrogen fuel station. We translated that into a concept called service area. And if we place enough service areas around the corridor and the roads, we can see areas where more stations are needed, for example. And that would right now look like this. This is a current snapshot of where the green ones are the available hydrogen fuel stations, which are already productive. And then the red ones are either planned or currently under maintenance, or maybe only under construction. So you see that there's, of course, still many gaps, but in the tool, then we can place more hypothetical ones based on suitability. And this way we can plan better and fill out the gaps with hydrogen fuel stations. There's also a login and authentication system. We have now made the app completely open. So during the development time, you needed an account to log in to even see the map. Now we have made it all open, and the user interface is more responsive and is a bit better to use. And only for specific functions, you like creating your own weights if you really want to play with your own priorities. Or if you want to provide some feedback, like a bug report, then you would create an account so we can associate the information in the database. Then I would actually use the time really to go through the app a little bit and highlight a couple of functionalities. This is now basically for me here a placeholder. So I will go here to the map, to the app. So that's just HyTruck Landscape Geoinformatics EU. The link will be shared for the partners who had already access. This is the same link. The new app is now online on the default location, so everybody can access. So the default layer here is the suitability. And as you can see, the shading is from red to green. And the type, let me maybe zoom in into more interesting locations here, for example, maybe somewhere here. Then you will see here the loading, the zoom will go in and get higher resolution suitability cell data now. On the left side here in the panel, we have additional data layers. So they can be opened and closed in order to explore auxiliary data. For example, power stations. So where would be power substations be? We can then also query power substations. That substation is actually under construction. Interesting. And that, I didn't get that one. And that's, those are typically those transformers and those things. Then we have 10T. This is a 10T airport here. You can see the, now when are the suitabilities coming now? Are people loading now more? Then we have each cell. If we click on the cell, the suitability provides you with the information of the different variables. So they were originally aggregated by us. We can see the different values, and then the derived suitability based on the weights. And here the weights, we have two default weights, as I explained in the presentation, for the HP derived one and the survey derived one. So if I would now click, then it would load a slightly different pattern, because so at least we see now the the higher resolution one, which is nice. Example, close to Rostock. Where's Rostock? Here's Rostock. Then we have information about wind farms and solar farms. Of course, the main 10T corridor. So here, this big, where is the main 10T corridor? Oopsie. So there are the roads. Shouldn't they be here? Here, 10T corridor. This is the North Sea Baltic corridor, the main one. And we have, other information like wind farms, the purple one. And as you can see on the left side in the panel, the legend will then show the legend coloring. So this way you can find the symbology for the data. Then an additional function that was quite neat is typically maybe you work in your specific pilot area or in your country. Let's say if we go to Latvia or Lithuania, then the suitability data would be clipped, so to say. You can see here now only for that area. And maybe we have to make the server bigger now that it's public. We were thinking that this is this might be a thing. And then just to show differences in patterns, just for the fun of it, that it's so I would go, for example, for Estonia, then and I have a setting here where I have very strong differences. And then we can see a much stronger. So that here I've weighted the distance to the coast really high and cities. And in order to look at those layers weight, this is then the next function here, layers weights. Right now, as you see, I'm logged in, so I can edit my own settings. If I were not logged in, then I would just be able to see them. So as you can see here, I weighted only the seashore, so distance to seashore, closer to the seashore is better. And then urban nodes, meaning that only closeness to urban nodes is good. So here I only focus on them, and then as we saw on the web map. Oops, where is it? So this is the default setting right now, and then we can see, you can immediately see the differences in the weight, so that gets calculated on the fly. So then what other things do we have? We have the different layers here. You can have also a different base map if you wish to. You can explore the different layers that we have added, especially those ones here, I think fairly interesting, the energy related. Then we have European hydrogen backbone information. So for the different years, and then import pipelines, I think they're only down here actually. They're part of the hydrogen backbone. So, and then a last interesting fact, functionality, if we think of service areas, and here in Estonia, we would say, okay, actually right now in Estonia, one service station here, we have this tool for the service area. So if I click that, for example, we know that there is one in Tallinn. You see, okay, the area being possible to cover from Tallinn, let me switch that off here for a moment, would reach, this is 100-kilometer reach. So in order to cover, then let's say we know maybe the next one is certainly in Riga. Oh, in Riga. I mean, we see a gap. There was a plan, or is a plan, for example, with the Pärnu one. That would potentially, cover the gap. So this way, then we can plan. Then a similar situation regarding planning, how far would it be needed? You could go, for example, then, okay, we have Kaunas and Vilnius. And then this is actually easier to see in OpenStreetMap. Yeah, and Panevich. So this way you could start building out in order to see would that reach sort of fit. In the end, we can download this. It's a GeoJSON for most people working with even a little bit with spatial data. This is a fairly well-known format. We get the center point. We can use it in other tools, in other web maps, or in desktop GIS tools, for example. And in order to clean up, we can then clean up like this. This is not being saved over a session. So this the planning for the spatial allocation is really more meant as a lightweight way to place around, clean up, and then if you are happy, you can download it to see. Okay, what other function do we have? Create editing suitability weights. I have feedback. So feedback, we have feedback. So this function is also available if you're logged in. So we can see you can submit a bug, or you can see historical feedback. Test. Oh God, what did I write here? Yeah. So I can delete that one. We don't need that type of feedback. Okay. And then in the about section is directly the link to the documentation. The documentation is also public. Right now, I would highlight the availability of the different data sets. So we want to eventually even link from the layer information here to which to get immediately you can get the background European hydrogen backbone that needs to be cleaned up a little bit more. But basically, you have the resting areas, the solar farms, where the data came from, some information about the data, the data types inside. And we have to update the toolkit documentation. But beyond that, yeah, the data and the documentation, that's all fairly open now. In addition, we would now have a bit of an outlook. So the deliverable is due now. So we'll add the last information on which functionalities are available in the app and add that to the documentation. During the course of the next year, we'll of course continue the maintenance and the documentation. Probably we have to make the server a bit bigger or do some performance enhancement for the web view or some of those things. We're still happy to collect feedback from maybe now a wider audience. Another thing that we are working on, it's basically there. We have to do a couple little polishing things. The data sources that come here, those layers that are here on the left, and the main suitability layers. The main two suitability layers for AHP and server settings, those will be able, you can directly query the data if you're a more technical power user. We knew that in the beginning that it was not so important, but now we have actually had a couple of use cases. You can then query this suitability data if you want to post-process this in your own workflows. Yeah, then we can have a bit more data. It's always nice if we've come across some nice data. So we have applied for the H2 availability map, which is now a European Commission level data set versus the sort of more closely managed H2 Live data set. We have repeatedly heard that traffic flow data would be interesting to see. We are looking into that as well. And the data and the source code is on the way of being made open source. So the data you can already directly query and download yourself. And we are currently starting to make the server application also as open source, which is also a requirement in the project anyway. That's me. Thank you very much. I think we might or might not have